Hi class, today we're going to do exponential functions, so let's get started. Say I offered to you that if you give me a penny on the first day of May, and then you give me 2 pennies on the second day of May, and then you double that to 4 pennies and 8 pennies and 16 pennies, and you do that for the entire month of May, I'll give you an A in the class. How much are you going to give me? Well, that's an exponential function, so let's have a look at it. Okay, so on the first day you give me 1 penny, the next day 2, the next day 4. So in day 3 you give me 4 pennies, and day 4 you give me 8 pennies, and that keeps on going on. So this is day 1, day 2, day 3, day 4, and we keep doing that all the way up to day 31, the last day in May. So how many pennies did you give me? Okay, well, in day 4 you gave me 1, then you gave me 2. Then you have the third day is this one, the fourth day is this one. So what's our formula for that? Well, it's going to be 2 to the n minus 1. We get on the first day 2 to the 0 is 1. On the second day 2 to the 1 is 2. On the third day 3 minus 2 is 1. 2 squared is 4. On the fourth day, so on, and it works. So on the final day, you'll give me 2 to the 31 minus 1, which is equal to 2 to the 30th, okay, which is equal to, a mere, let's see, we got 1, 0, you can try it on your calculator, 737, okay, it keeps going, 41824. Oh, but luckily that's in pennies, so I put a decimal place there. Boom, boom. You give me 10 million bucks. Okay, that's an exponential function. So it goes up pretty quick. Let's have a look at these. Say if y is equal to 2 to the x, which is a very typical exponential function, right? There'll be a time period where your money doubles, which is basically the factor for all exponential functions, and I'll show you that. What's the graph of that? Well, if we put 1 in for x, we get 2 for y, right? So 1, we get 2. If we put in 0 for x, 2 to the 0 is 1, so we get 1. If we put in 2, we get 4. For 2, we get 4. Okay. For 3, 2 to the third is 8, so we get 8. And it goes up quick. And the next one is, if we put 4 in, 2 to the fourth is 16, right? It doubles every time. So 4 is 16 way up here. Okay, so we get this curve that looks like this. Now, can we put negative numbers in? Sure. Minus 1. Let's see, we get, we can also put it as like f of x, our function, is equal to 2 to the x. So f of minus 1 is equal to 2 to the minus 1. Which is equal to 1/2, or 0.5. So 0.5, so at minus 1, we get 0.5. What about minus 2? F of minus 2, well, f of minus 2, that's equal to 2 to the minus 2, which is equal to 1 over 2, and which is equal to 1/4. So we get 0.25. Every time it goes down by 1/2. So we keep getting closer and closer to 0, but we never quite get there. And that's basically what an exponential curve looks like. Now the domain is equal to, basically I can put in any value for x. So all numbers I can say from minus infinity to infinity, or all reals or something like that. What about the range? The range is a set of output values. So what can y be? Right? Y is a set of output values, x is the input. So what can y be? Y can be any positive number, and exactly that. It doesn't get down to 0, so not including 0, and any number greater than that. Okay, let's have a look at a couple of graphs because that's pretty cool. All right, we can go to this, we've seen it before, this Desmos graphing calculator, and we can say y is equal to x, right? We just get that straight line, but I can also say, how about 2, and we get that flat line, 2 raised to the x. Let's go up here and put an x in there, and we get that curve. Exactly that, right? Here's 0, 1, here's 1, 2, here's 2, 4, here's 3, 8, and so on and so forth. And we can shrink this down. We look at it like that. Now let's make a different curve. Let's say we have 1.07 raised to the x. All right. Well, it looks like that too, but if I shrink it down, it basically looks like the same thing. There's going to be a period for x where this is equal to 2, and it doubles every time like that. So basically all exponential curves look like this. All right. All the domains here gets closer and closer to 0. The domain gets from 0 to infinity. The range is from 0 to infinity. And you always have the point 0, 1, and the range is from 0 to infinity. The domain is, you can put in any value in for x. And let's see that again. Let's put in a 1.5. Okay, then it shoots up like that. But it's basically the same thing. There'll be a time where it doubles each time, and x for some value x. So it basically looks like that. Okay. Now, a very important example in exponential graphs is a is equal to p times 1 plus I to the t. This is an interest formula where a is equal to the amount that you'll have. P is equal to the principal. I is equal to your interest rate. And T is time, typically in years. Now for compounding monthly or quarterly or anything like that, you have the interest rate divided by n to the n times t, where n is the number of compoundings per year. So let's say you started with a principal of, say, let's just start with an easy number, $10,000. You have an interest rate I of 7%. Okay, you're going to compound it monthly, so n is equal to 12 periods per year, and let's just say t is equal to 5 years. How much do you have after that? Well, a is just equal to the principal times 1 plus the interest rate, 0.07, that's 7%, over 12 to the 12 times 5. Okay. Okay, so we had 10,000 times parentheses 1 plus 0.07 divided by 12, and then we raise that to the 12 times 5, which is 60. Raise it to the 60, and after those 5 years we have that amount. And so the amount that we'll have after that is equal to 14,176. 14,176, and that's in dollars. Okay, so that's the essence of exponential functions. I hope you found this video useful and enjoy your day. Cheers.